All right, so here we got one. A company makes wireframes as pictured here. And so instead of below, I put it here to the right. And so we have a circle top, and then we have this square bottom. We have the lines coming down. And what it says is each frame is constructed from wire is a total length of 9 feet. And it's cut into 6 pieces. So we have one piece here, one piece here, one piece here, one piece here for the four uprights. We have a piece for the circle, and we have a piece that's bent into the square down here at the bottom. Now it says the vertical edges consist of 4 pieces of wire that are 12 inches long each. So each one of these is 12 inches. Okay. So if we mark all those as 12 inches. Now one of the remaining pieces is bent into the square to form the base of the frame. All right. Well, if these are all the same side, usually we label that as X. So maybe, we could say those are all X and we'll just label it as X. And now the final piece is bent into a circle, and it's going to be the top of the frame. All right, so a circle, and so we can call that C is going to be the circumference, because we're going to know that, and that's what we need to do. So circumference is, well, that's going to be 2 pi r. So again, that might be something you need to look up if you don't remember what circumference is, and so we'd have that. So what we have is now, into what length of pieces should the wire be cut to minimize the combined area of the circular top and the square base of the frame? So our first step, remember, is for optimization. So for the output, we want to optimize basically the combined areas of the circular top and the square base. All right. Now, what are our inputs? Okay, well, our inputs, we have the circumference of the circle, and we have, each of the sides of there. So we have C is the circumference of circle, and we have X is going to be a side of the square. Okay. All right, so that's the first part. Now, the second part is really what we did already. So, they gave us two, and all I did is went ahead and labeled all the pieces kind of as we read them along. And so that's really what step two is. Now, sometimes, they do give us a picture, and all we have to do is kind of label what they give us. But sometimes we actually have to draw the picture from the words. And so you have to understand how to do that. Now, for part three, that's going to be setting up the equation. So that's going to be probably one of the harder parts. Now, what do we know here? um, let's see. We know that we have 4 pieces here, right? So there's 4 times 12. So we'll have 4 times 12 plus, now we have 1, 2, 3, 4 x's, and then we have plus, now we have the circumference, but we don't know what that is. So we'll just say plus C, and that's going to be equal to, and it says 9 feet just cut into 6 pieces. So the total is 9 feet, but if we have everything else in inches, we should probably convert the feet to inches. So we'll say 9 feet times 12 inches per foot, and that'll convert this to inches. So everything now is going to be in inches. Okay, so if we simplify, that's going to be 48 plus, that's still 4x, that's plus c equals 9 times, that's going to be 108. Okay, now what can we do here? Well, we could simplify and solve for c, because a lot of times you'll find that if the way we set up the problem, if we have x, we're going to use x as far as our variable. So we say c is equal to, well, 108 minus 48, that's going to be 60. If we take 4x over, that's a minus 4x. And so now we've got all the length of the total wire solved based on the circumference of that circle up top. Okay. Now, what else do we know? Well, now this here part, circumference equals 2 pi r. So maybe we need to have the area of that circle, right? Because we have to know the area of this. We need the area of this. So let's go, maybe we'll kind of do that so we can kind of do some stuff over here. So the area of the circle is going to be what? Well, that's pi r squared. Now, if we want this in terms of something that we're working with already, we're working with c's and we're working with x's. So can we get this in terms of a c with replacing that r? Well, if we solve this for r, if we have c equals 2 pi r, solve for r, we divide by 2 pi, then we get r is equal to c over 2 pi. Now, this is in terms of c, this is in terms of c, so what we can do is we can plug that in here, and the area of the circle is pi times c over 2 pi squared. Now, what else can we do? Well, guess what? Now we've substituted here. Now we can take this c and plug it in here and get rid of that, and then we're in terms of only x. And so if we do that, maybe we should move over a little bit so we have more room. Now we have a of, again, it's still of c right now, but so let's leave it as that is equal to pi times c, which now is 60 minus 4x over 2 pi, and we're still squaring it. So all we did was we put in this right there, and this one, we plug that in there. And so again, this is following along as you go, you remembering what piece goes where and how it works. And so we haven't broken any rules yet. Now what I'm going to do is I'm going to suggest squaring this and getting rid of it, because then maybe we can get rid of some pi's. So that's going to be pi. And then if we actually multiply that out, that's going to be 60 minus 4x times 60 minus 4x, because we're squaring that. And on the bottom, we're going to have 2 times 2 is 4, pi times pi is pi squared. And so now we do this, 60 times 60, that's 3,600. So we'll have 3,600. And then we'll have minus 240, so that's minus 480x. And then we have minus 4 times the minus 4x, that's going to be plus 16x squared. Okay. All right. Now let's do some cancellation. Now, one of these pi's cancels one of those, so we just have one pi in the denominator. It looks like now 4 will go in here, it'll go in here, and it'll go in here. So 4 will go in here and leave us with 900. 4 will go in here and we'll have a minus 120. And 4 will go in here and we'll, oh, that should be an x still. And then that will be a 4x squared. Okay. So we've kind of reduced that as much as possible. So now we have area is equal to what? Well, if we write it in decreasing power, that'd be 4x squared minus 120x plus 900 all over pi. Okay. So that works. So that's the area basically of that circle up there. Okay, so that's what we just found is the area of the circle. Now, what is the area of the square? Well, the area of the square, let's call it AS for the simplicity, circle, square. Well, that's just going to be x times x, which is what? Well, that's x squared. Okay, so that was easy. Now we know the area of the top, the area of the bottom, and what we want to do is we want to minimize the combined area of the circular top and the square base. So that means we're going to combine the top and the bottom. So we're going to add this to this, and we'll find AC plus AS. And that's going to be a total, okay, between the top and the bottom. All right, so now I'm out of room, so let's go over here and say, all right, now we have the area total, and we can probably break it down to just AT here in a little bit, is equal to, well, the square is x squared, and the circle we said was, now here we had all of these divided by pi. So maybe what we should do is take and put each one of them over pi. That way it's going to make it so we have them split apart a little nicer. And if we do that, that's going to be 4 x squared over pi, and then it's going to be minus 120x over pi, and then plus 900 over pi. Okay, so again, we just took each one of those over pi. So that's the circle, that's the square. Now, what do we have here that we notice? Well, we notice we have an x squared and an x squared. So maybe what we'll do is we'll pull out an x squared here, and what's left is 1. Then we have plus, and here we have 4 over pi. And then what do we have? Well, we still have the minus 120 over x, 120x over pi, and then plus 900 over pi. Okay. Now, this is an x squared and an x and that. So this is going to be what? A quadratic. Okay. Now, what do we know about this? Well, it's a positive here. And so it's going to be open up. And so what's going to happen is this is going to be a min. Well, guess what? We wanted to minimize that. So what we need to do then is we need to take the derivative. So we need to find a prime of t, and it's all going to be of x because now we've put it in terms of x. And so we're going to set that equal to 0 and find what x is. Okay. Well, what I'm going to suggest is let's use our calculator, and we can do that immediately. I mean, we could go ahead and take our a prime, a prime of this is going to be equal to, well, it's going to be, 2x times 1 plus 4 over pi, and then that's going to be a minus 120 over pi, and that's going to cancel out. And so this is what our derivative is, and we can set that equal to 0 and simplify, and it's going to be a line. But I suggest let's go ahead and do our calculator, and then we don't have to worry about all that. We can just plug in what our ax is. It'll take its derivative, and we can find where it crosses here. So let's clear that. And we said it was going to be x squared times 1 plus 4 divided by pi, parenthesis, and then we had minus 120x divided by pi, and then we had plus 900 divided by pi. And now hopefully we have the area already. Oh yeah, so we got that good. All right, so like I said, it's going to be a parabola opening up, and it's going to be crossing at this point for the derivative, which, we said it's going to be a straight line. We just didn't want to solve that line. And so now we just find where that's at 0. Okay. Now we don't want the blue line. We want the red line here. So that's below. That'll work. We can set that as a left. Now we'll go above. We'll set that as right. And it says 8.401 is our x. So it says x is approximately 8.401. Okay. Now, what are units? We're in inches. So that's going to be 8.401 inches. Okay. So we can get our area here. We can plug in x squared and get the area. We can find the perimeter, which is probably more likely what we need to do because we're going to need a perimeter here, and that will help us know how long that wire is. And then once we have that wire, all 4 of those wires, we can then solve for how long that wire is. So let's go ahead and start doing some of this. So if we find the perimeter of the square, well, that's going to be 4 times that. And so we take that times 4, we get, let's go back over here, we get 4 times 8.401, and we get 33.604. So that works. So we get, where'd my pen go here? 33.604 inches for the perimeter, for the base. Now, what else do we have? Okay, well, our circumference, if we remember over here, our circumference is 60 minus 4x. All right, so circumference is equal to 60 minus 4 times x, which is 8.401. Well, we just found what that was, so it's 60 minus the 33.604, and that's going to be what, 26.396 inches. All right, so that's the circumference of the top wire. So again, if we draw everything here, we kind of had, we had some kind of a square, but we didn't draw our pieces in the right place. That should be over there, but that's beside the point. So that should go up. All right. So now we have that. So we know the circumference is 26.4 roughly inches. Our bottom piece, the perimeter, is equal to 33.6 inches. Each one of these was 12 inches. And so hopefully, if we go and add all those together, we're going to have 4 times 12 plus 33.6 plus 26.4. And we said that was supposed to be 108, if I remember right. So that's going to be 48 plus, that's going to be 3, 4, 5, 60. And that gives us 108. That does check out. And so that is going to be the circumference. That's going to be the perimeter. Now, what does it say we're supposed to actually have? Into what length pieces should the wires be cut to minimize the combined area of the circular top and the square base? Well, we need the top to be 26.396 inches, and we need each of those to be that, and so we need a total of 33.604 inches around the base. And so that is going to be one piece of wire, that's going to be the other piece of wire, and we already knew those 4 pieces were each 12 inches. Okay, and so that's going to be how I would solve that problem. Again, this one, they gave us a lot of this stuff already in the drawing. We just had to apply it and go and do each step to get to the point where we could actually go ahead and do this part here, which is the easy part, taking the derivative, setting it equal to 0, finding what that intercept is on the x-axis, and then going backwards and solving for each of the individual parts that we need to do. Okay. All right, so let's stop there and I'll come back with another one.